So this is a review for our unit test tomorrow. It covers 6 methods. So we're going to talk about void methods, parameters, primitive versus class parameters, returns, method overloading, and recursion. There are 10 multiple choice questions and 1 short response. This is only worth 50 points. I didn't think it'd be justified making it worth 100 points because it's really like a really heavy quiz. I don't even know exactly how to count this. So I put it as 50 points rather than 100 points. The project is 50 points, so the two end up giving you a score. This is of 100 points, summative points for the thing. I thought that was a fair way of weighting it out. Compared to Unit 3, whereas Unit 3 was several modules that deserved to be 100 points. Okay? So this is worth 50 points. Let's just dive in here. Void methods. This was our entry into methods and talking about how to use them, the very basics of them. So we talked about using the idea of method decomposition, breaking down tasks into smaller pieces. Like, for example, if you have to calculate an average, creating another method called sum that adds everything up for you would be a good example of method decomposition. Creating a method called sum and then doing the sum again inside the average doesn't make any sense. You already wrote the code once, it doesn't make sense to do it again. The basic structure for a method: you need the public declaration so everyone can have access to it. We'll talk more about public and private in a future lessons. Static means you don't need to create a class for it. So we've been doing public and static in every method because we've been containing those methods inside the main class that we're working on. Void means it doesn't return anything. That was the first kind of method we looked at. And then do stuff. It just, some name. Our first methods didn't have any parameters, so we just put 2 sets of parentheses. You have to have the parentheses. Java will get really mad at you if you don't have the parentheses. And then we just did something in there, just like a simple print statement. When you call it, you call the method by its name, and you have to, again, include the parentheses. So again, here's the simple structure: public, static, void, the name of the method, parentheses, curly Q, and inside is your commands. Public, static, void main is technically a method. It has parameters. It takes an array of strings. So this is our parameter. Remember, we have to set up we have 2 vocabulary words that are really important here: parameter and argument. Parameter is when you set up the initial declaration of your method. The argument is what gets passed in when you're actually calling the method. So those are 2 important vocabulary words. The point of why we do this is code reuse. The methodology is called refactoring. Anytime you have code that you repeatedly reuse, it makes sense to build it into some type of method, rather than just cutting and pasting it. If you have to decide later that there's some reason to change that section of code, then it's easier just to change it once than it is to have to go through and find it every occurrence inside your script and change it then. It just makes a lot more sense to change it one time rather than changing it 10 times. Programmers don't do stuff just for the fun of it. Everything is designed to be functional to make their lives easier. It's not necessarily easier to understand, just easier for them to do. So that was lesson 1, the basics. Then we talked about lesson 2, parameters. Here we go. So the parameter is the local variable in the method header that holds the data set. The argument is the information being sent in. We have to make sure we get those two words right. Parameter is in the local variable in a method header that holds the data set. Here's an example of two parameters here. Int A, int B. You have to declare the type in the method header. Do you remember what this is called in here inside the parentheses? Begins with an S. Signature. Okay, we'll talk more about that when we get to method overloading, but this is called the signature. The order and type of parameters inside those parentheses is called the signature. The order and type is called the signature. You would have, these are your rules for parameters. You have as many as you need. There's no limit on them. You can have any combination of types. The values are from the main or calling method, and those are called arguments. Definition of the argument is the data that's sent to a method. The argument data type must match what the parameter is expecting. The signatures have to match, essentially. So here's a parameter right here, int x. That's the parameter. The argument right here, when we actually call the method. So A would be the argument. Parameter. Inside the header, definition for the method. Argument, when we actually call it, and we send it as a value to the method. Let me have some practice. So, class parameters versus primitive parameters. The major difference here is class parameters create aliases. So if I send an array, which is of class type, as an argument into a method, and I change it inside the method, I don't return anything, I just change the array, it changes it for everywhere. So if I can kind of draw this out, let's say this is my array in my main. But what's really happening here is this is really just a variable name that is pointing to a table of data. So when you call the method, you're passing the reference to this table. They're both pointing to the same table. So if this method changes this table, then it changes it for this, because they're both pointing to the same thing. So when you're passing something that is a class type parameter, then it is going to change it. The one exception, and this makes it, as a teacher, this makes life so difficult, is a string. If you send a string, yes, it's class type parameter, but it won't change the original. Okay, string is the exception. So how does the AP exam handle that? They don't. They don't ask you questions where they send strings as parameters. If they were going to ask this question about parameters, class types, then they send an array. So if the AP exam was asked this question, they would not ask it about a string. They just avoid it. Strings are those things that happen, that behave oddly like primitives and like objects. Right? They kind of have elements of both. So the AP exam stays away from that. The reason they stay away from that is because it's supposed to be language independent. And that's pretty much a Java thing. So when they ask this question, they're going to be asking it in such a way that you don't have to worry about that. They'll ask it about an array or some other type of object. We'll create, and when we start learning how to make our own classes, we'll see that. They'll give you some other type of object reference. So the thing that you have to know is true, that if you send an object as a parameter, as an argument into a parameter, and you change it, it's going to change it everywhere. That's what you have to learn out of this. Kind of forget the string special case for now. It's there, but more in practice than in testing situations. So let's talk about returns. Returning information is pretty straightforward. Couple rules about it is you have to return one value. If you're going to return something, you have to return just one value. You can't return multiple values. You can return an object. So you could send an entire object that kind of packages it all up for you, but you can't send like an int and then a double and then a string. You can't do that. You have to send just one thing, either as a package or as a primitive, but you can only send one thing. Return statements must exist if it's in the declaration. So in your method declaration, if you don't say void, if you say int, you have to return an int somewhere in your code. And you have to make sure it's obvious to Java. So if you have a condition in there that you think will never kick out of it, in other words, if you have an if then else, but instead you have an if and then an else if and not another else, there's a good chance Java's going to throw an error because it'll say, well, you don't have the default condition. So technically, there's a possibility that you may not be returning an int. And that's the tricky part of returns. You have to make sure that no matter what condition happens, when that method is called, it will return an int. Even if it's just 0. It has to return an int. In addition, that when you call the return method, it kicks out of the method immediately. No matter where you are in the method, if you're in a loop, a while loop, a for loop, if you're in the middle of an if statement, it doesn't matter. Whatever else happens after that, as soon as the return command is executed, the method is done executing. That's it. So in terms of structure, sometimes you don't really need an else. You could just put your last statement as a return. And we saw that in some of the examples of this, that if your last statement is a return rather than an else, then it will treat that as an else because there's no other code to execute after that. Even if there were more lines of code, it would ignore it. It would just kick right out of it. Also, you can use a return in a void method. This is the question that people got wrong. You can use a return in a void method. The way you do it is you return nothing. Void methods don't return anything. So if you just write the command return and put nothing after it, that will return nothing. So it definitely works. So here's an example where we're using a return statement to be treated as an else. There is no else here, but technically this return B behaves like an else. If A is greater than B, return A. It will never get to this statement if it executes return A. It kicks out of the method altogether. So really, this is only going to be executed if A is not greater than B. So it behaves much like an else does. So there's a nice example of using a return method to kick out of a method in order to replace an else. Because as soon as this return A is hit, even though this return B is outside the if statement, and in any other segment of code it would be executed, because we hit the return A, it jumps out of the method. It doesn't matter what else is after it. It's just done. There could be 1,000 lines after this. It hit the return A. It's done. Jumps out of it. So this really kind of structure here behaves like an else for us inside of a method. If you decide you don't like the structure and you want to use else's, that's fine, use else's. It doesn't really make a difference. It's just, that's one of the, I guess, prettier versions of using this statement. So here's an example in code of it running. We saw that before. Okay. You must catch the returns. So when you call a method that has a return, you must catch it, you must catch it properly. If it's sending back an int, you have to store it in an int. Now you might cast it to something else, that's fine, but it has to be captured in some way. You have to be prepared to catch the int and do something with it, whether it's printing it out to the screen, storing it in a variable, casting it as something else and then storing it in a variable. That's fine too. As long as you're doing something with the return, then you're handling it. If you just call the method and then let it just kind of sit there, you're going to have a problem. It's going to give you an error. So here's an example of it being caught. This returns a value that's being stored in X. Here's an example of it being printed. Again, it's being caught by a print statement. Here's an example that's being used as part of a conditional. Again, it's being caught. Something's being done with it. So there's lots of different things that you can do with it. Okay, and then this was just some example code. So we send method using parameters. We could have many parameters. The method sends data back using a return. We can only have one return. Many parameters, one return. Okay. So method overloading is when a program has more than one method with the same name. It's the signature that is Java's way of determining what method it should be talking about. Each method does the same kind of thing that might do a slight variation on it. And it does the operation on the same, or different sets of data, excuse me. So here's an example, substring, we've seen that. It's overloaded. One version of it takes an int, another version of it takes two ints. Both return the same thing. So here's another example. We have a sum that takes two integers, and then we have a sum that takes an array. These are our signatures. Two ints or an array. Other than that, they're exactly the same. They return the same thing, they're called the same thing, the exact same structure. The difference is the signature, and the order and type is what the signature is. Order, type, and number of parameters. So it's the number and types of parameters that is allowing Java to tell these apart. This signature right here. Signature does not include return type. Why? Because if somebody called the method add here, there would be no way for Java to know which method to use. Because the user is not telling them what the return type should be. The user is just telling them, I'm calling add and I'm sending some type of integer to you. Java like, wait, which one of these two do I use? Do you want a double or you want an int? There's no way Java has of determining which of these two it should use. So the signature, you don't overload with two different return types. It doesn't include the return type. When you're overloading a method, good practice is always make it return the same thing, but the real signature comes in right here between those two parentheses. Could you make it so it returns something different? I believe you can. However, just because you can doesn't mean you should. I would make something totally different at that point. But you would have to have two different signatures. Maybe this one sends a double instead of an int, and then returns a double. We saw that, right? Absolute value. If you send a double, it returns a double. If you send a int, it returns an int. So there's a good example. But it's not the return type that matters, it's the signature that mattered in that case. Okay. So I'm just going to jump to the recursion part too, we're returning things, because that just makes the most amount of sense to talk about the whole thing together. Recursion is essentially a method that calls itself inside the method. So that's the first way that you identify as a recursive method. There are two major things that you have to find in the recursive method. What's the base case? What's the thing that stops at the top of the stairs? And then, what's it returning? What's it sending back? I'm not going to ask you to write a recursive method. The AP exam's not going to ask you to write a recursive method. You have to be able to trace them. So you have to be able to follow the steps. Go all the way up the stairs, find the base case, come all the way back down the stairs. Yeah, I think drawing stairs is the best way to trace it. Like I would start, right? You keep going up and going up and going up till you get your base case. So maybe here, let's say our base case is when x equals 0, right? So x equals 5, then we call it again. X equals 4, x equals 3, x equals 2. Steps. Let's call our base case x equals 1. X equals 1, base case reach, and then I go back down under the stairs, just to remind you, so maybe I'll return the value, 1, and then I sum it, so 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, 1 plus 2 plus 3 plus 4 plus 5, and that goes back to the original calling method. So I'm really kind of going up the stairs on one side and then back down the stairs on the other side to keep track of it. And that's really what the Java Visualizer does too. It gives you a memory block for each one of these, because that's what's happening in memory. A new version of variables, a new version of everything gets created in memory every time that method gets called. So you're really just following it up the stairs. And I like the analogy because that's what we started with, the Statue of Liberty example. You pass the question all the way up, how many people are in front of you? The base case, there's nobody people in front of me. So then you return by always adding 1, going down the line until you get to the last person. If you kind of keep that example in the back of your head, you'll remember what recursion is. And you got to trace any recursive method. So whether it's printing something on the screen or actually returning a value, it's going to be the same type of thing. If it's returning a value, then the next call is going to use it. If it's printing something on the screen, that's just going to print something to the screen. So you can kind of think of this as either the value that gets returned or what's on the screen. Either way, you're going to get the same type of tracing action. So recursion, the big thing here is be able to trace it. Go through and trace what's going on here. Here's our base case. Then equals 0. This is what's going to stop it. This is where we are calling it. This is the pattern. We're always subtracting 1. So if you were to write your own recursive method, you kind of have to find that iterative piece, the piece that it's repeating. But since you're not writing your own, all you really need to do is identify where it is in code. This is the part that's going to keep calling itself over and over again. So each time we can tell this, we're going to be subtracting 1. So if I got a 5, then the next time I called it would be a 4, then I'm going to call it with a 3, then I'm going to call it with a 2, I'm going to call it with a 1, I'm going to call it with a 0. Wait, there's my base case, now I'm going to start going back up, or back down, however you want to think about it, through the stairs. So send back the 1, send back the 2, send back the, and I'm summing them. So just add them all up. So that's that example that I just showed you on the board with the stairs. This is essentially the code version of those stairs, just adding it back up. So that's the goal there, be able to trace that bit of code just using that stair structure. So our unit test will cover all these things. And then, of course, you guys should also be working on binary calculator. All right? Never stop coding.